Now that we have our series circuit complete, I want you to export this into an Excel file, and we're going to have our Excel file create our calculations for us. So the way we're going to export this is we're just going to highlight the whole series circuit. So we're just going to click on one side, and go to the other side and highlight everything in our circuit. Once we have everything highlighted, we can do this a couple different ways. We can go to Edit and Copy, or we can just hit Control C. I'm just going to go to Edit and hit Copy so you can see what I'm doing. Now that we have this copied and attached to the clipboard on our computer, we're going to go to our Excel program. I already have our Excel program open, so you would want to open Excel, and then we're just going to put this kind of in the center of our spreadsheet here. We'll come down about to row 6 and then row D maybe, and just click there, and then we're going to right click, and then we're going to do a special paste. We're going to paste special, and we want to paste a picture into our Excel file. We're going to use our CAD drawing as a picture, and we're going to do that so we can edit it a little bit. So we're going to click OK, and as you notice, it's making a very large picture in our Excel file. We do not want that picture to be that big. So what we're going to do is come up to the top in our picture format tab, and we're going to click on our picture format, and then we're going to come over here to crop our picture. So we're going to make our picture a lot smaller than it actually is originally. So we're going to bring our sides in, and we want it to be just a little bigger than our actual picture is. We will have to arrow over to get to where we can see the rest of our crop. And we're going to bring this down, and then again we're going to have to arrow over to get the other corner. And we're going to bring this in to where it is just about the size of our series circuit. And once we have it where we want it, we're just going to click off of it, and then it's going to make our series circuit a lot smaller. We'll be able to get into our files here. I do want to move it over just a little back to where we kind of had it. I'm going to arrow over here and move this back around D4, and it's low a little bit, so we're going to bring it up just to center it in our drawing, so if you ever wanted to print it. And we're also going to line it up with one of our blocks, so we can put some labels in here and make our blocks a little easier to read. So we're going to kind of center our resistor in column F here, just so that we can align it a little better. So I want to click on the top up here, and we're just going to name this R1. So we're just going to hit R1, and we're going to name this one R2. We're going to name this one R3, and this is going to be our VS for our voltage source. So in our series circuit, we know that current is flowing in a loop and that our resistors are adding up. So we're going to make a little title block down here so that our Excel file will do our calculations for us. Okay, this is how we're going to create our table. We're going to click on D29, and we're going to click and hold our mouse and drag, and we're going to go over 5 cells. We're going to come down 5 cells. Is that 5 cells? That looks like 5 cells. 1, 2, 3, 4, 5. And then we're going to right click on our table. We're going to go to Format Cells, and we're going to put a border around it, and then we're going to fill in the lines on the inside. So now we have made our cells. And we are going to put resistance. We're going to do voltage. we're going to do current, and then we're going to do power. And our Excel file will do these calculations for us. So you notice our resistance is a little bigger than our box. So we're going to come up here and make our column D just a little larger so that it will be able to hold our resistance and it will be in that box. Now at the top up here, we're going to put our resistor. So this is going to be R1. We're going to put R2, and then we're going to put R3. And then at the end here, the last column, we're going to put our total. So this is going to be the resistance of R1, this will be the resistance of R2, this will be the resistance of R3, and this will be our total resistance. So I would just like to maybe make this a little neater, and we're going to format these. We're going to center these values in our blocks. So we're going to come here and we're going to align them horizontally. We're going to center them horizontally, and then we're also going to center them vertically. So they will be centered in our box. So to do our calculations here, we're going to come to our box for our total. So to calculate our total resistance, we are going to add R1 plus R2 plus R3, and that will give us our total resistance. So if we come up here at the top at our toolbar, and if we do auto sum, if we just click on that, it will ask us to add these numbers together. So that's going to put the sum. If you come over here and click and highlight these three cells, it's going to add those three cells and put the total in this cell here. So we highlight those three and we just hit enter, and then those three values will be totaled here. So if R1 is going to equal 1,000 ohms, and if R2 equals 2,200 ohms, and R3 is 470 ohms, this will be our total resistance. So this Excel will add our resistances together for us. Now that we have our resistance, where it will automatically calculate the total resistance if we just add in our resistant value. So we will input this data, and the Excel file will do our calculations for us. So for our total voltage, again, we will just input that data into our table because the total voltage would have to be a known. In this case, we're just going to make up a number and we're going to call it 30 volts. So to calculate our total current, we'll just use our Ohm's law. It'll be voltage divided by resistance will give us our total current. So we're going to allow our Excel file to do our calculations for us. So again, we're going to go to sum, and that's going to make us our formula down here. But we don't want to add these up. We want to do a division. So we're going to delete everything but our equal sign so we can start knowing that it is a formula. So we want to divide 30 by our total resistance. So 30 is in column H31. So we're just going to type in H31 and then hit the divide by sign. You notice it is highlighted. So it's going to take this value and we want to divide it by this value, which is H30. So we're just going to type in H30. And you notice this becomes highlighted. So it's going to divide this column by this column. We'll hit enter, and then this will put our value in here. And you notice this number has a lot of zeros in front of the decimal point. So this would be 8.1 milliamps, but we can't really see that. So we want to put this in engineering notation, and Excel will be able to do that for us. So the values of our current and our power will need to be in engineering notation. So we're going to highlight those cells that have our current and our power. And we're going to come up here to the top and we're going to go to our number tab and we're going to click on the little icon at the end of our numbers. And this gives us a way to format the cells according to how we want those numbers to be displayed. So we're going to come down here and make us a custom display for our numbers. So we do not want the general, so we're going to highlight that and we're going to delete that. And we're going to add two hashtags or pound signs, as us old people call them. And then we're going to put in a 0 and a dot and 2 zeros. That will give us 2 decimal spots. It will round it off to the hundredths column. And then we're going to put us a capital E, and then we're going to put the plus sign, and then we're going to put us another 0. So this is going to show us the exponent, and it's going to round it off to the 0. And then we're just going to hit OK. So now that is going to make our current in engineering notation, which should be 8.17 milliamps. So to get our total power, we're going to have to multiply our voltage times our current, and that's going to equal power. So again, we're going to go to our so we can come up here to our auto sum, or if we just highlight that box, type in the equals sign, and then we want to, so that will tell it we're wanting to do a formula. So we were wanting to multiply H31 times H32. So we'll just type in H31 and multiply that by H32. And then we'll hit enter. And then it will put it down there. And we've already made that into engineering notation. So that's 245.23 milliwatts is going to be our total power for this circuit. Once we know our total power, we're going to calculate the different values for each resistor. So we know in a series circuit that the current is the same for each resistor, because all the current that leaves the battery has to go through each resistor. There is no other path for current to flow. So to calculate that is just all of these are going to be the same. So to put that in our table, we're going to just highlight our total current, and then we're going to come up here to the top, and we're going to highlight our formula, and then we're just going to copy that, a Control C. And then we're going to click off, and we're going to delete that, and then we're going to come back to our R1, and then we're going to hit a Control V, and it's going to paste that value in there. So we'll paste the value for our current. That will be the current flowing through each resistor. So if our voltage changes, if now we have 24 volts, we hit enter, that's going to change our total current, that's going to change our total power, it's going to change the amount of current flowing through each resistor. So R1 would have 6.54 milliamps flowing through it, as well as all of the rest of the circuit. So that's how we're going to get our Excel file to calculate our values for us. So now we have to do the voltage drop across each resistor. So our voltage is forcing the electrons to move. So as it goes through a resistor, we lose some of that force. So as it's pushed it out, we will lose all of our force by the time it gets back. So the voltage drop across each resistor must equal our total voltage. So for Excel to do this for us, we're going to click in the R1 voltage cell, and we're just going to type in our equal sign again, so it will know that we are doing a formula. So to find voltage, it is just current times resistance. So we are going to use our E32 file, E32, and then we're going to multiply that by E31. I'm sorry, E30. So this will be our voltage at that. And again, it's in engineering notation, but it is just 6.54 volts. That 0 just means it's in the same thing. So we're going to do that for each one of those boxes. And I'm going to let you do those, and I'll show you how to do the power. The power, again, is voltage times current. So we'll come down here, we'll hit our equal sign, and we'll do this voltage times this current, and that will give us our formula for our power. I did not hit power. So I forgot to hit the multiplication. So we're going to hit equals. We're going to do this, and we're going to multiply it by this, and then hit enter. So that's going to be our 42.7 milliwatts is how that is. So I'm going to let you guys complete the rest of this table. But before I end, I would like to show you how to clean this up a little bit. Our table looks really nice, so you can add the formulas for R2 and for the power of each of these. I would like to center these. So if we click on that, we can go to our file format, and we will center each of these numbers. We go to alignment, and we will center them. So I would like for you to center all of your values here. And I wouldn't mind, I would like for you to be a little creative here and add some filler around these. So you can make a little box that will go around your drawing. You can do whatever color you would like. Okay, I would like for you to also put like a title across the top of your drawing. So just come over here somewhere in the center of your box. ABC, it's wherever you choose to be center, however big you like to make it. And then we're going to merge those and center those. We're just going to call this a series circuit. And it should center that in that box. That is way too small. So we're going to highlight this and make it a lot larger. And you can be creative with this, however large you would like it. And it will center it, and then you can also change its color. Make it purple, or make it green, or make it whatever color you would like. So I would like for you to have it highlighted and boxed in, and then the number up there. And you can change the color of these fonts if you would like. Just be a little creative, but I want to make sure that this part is working down here. So when you get it the way you want it, come to File and do a File Save As, and cause this series circuit and save it in your CAD folder, and then submit it in the submit box in Blackboard.